Okay, so question 10a. This question's just like it's a little bit of a nightmare algebraically, but it's not that hard. All we're doing is substituting this value here, minus b on 2a, everywhere we see x in the equation. And that's going to tell us, well, we know this is x and this is y. That's going to tell us y. So y equals ax, so minus b on 2a squared plus b times minus b on 2a plus c. And hopefully we're going to manipulate this until we end up with this thing as the y value. Don't forget the discriminant is b squared take 4ac. So let's play with this. We've got y equals a times, now negative b over 2a all squared. The negative cancels out, like negative 1 times negative 1. We end up with b squared over 4a squared plus negative b times b is b squared over 2a plus c. Instead of having this minus here, I'm just going to put minus here. So this a and one of these a's cancel out, and I end up with b squared over 4a take b squared over 2a plus c. Now, I want to get everything over a common denominator. So I'm aiming for 4a on the bottom, yeah? So I've got 4a on the bottom on this b squared over 4a, but this next one, I'm going to have to times everything by 2. And this c, if I'm going to end up with 4a, I'm going to have to times it by 4a on the top as well. So I've got b squared over 4a take 2b squared over 4a plus 4ac over 4a, which means I've got b squared take 2b squared plus 4ac all over 4a, which means I've got negative b squared plus 4ac all over 4a. Considering I know I'm aiming for b squared take 4ac, I'm going to take the negative out the front, negative b squared take 4ac, and this is all over 4a, which means I've got the negative of the discriminant over 4a, and I'm done. Now it actually wants us to use this in 10b. It actually wants us to use this for each of the following quadratics, use that formula to find the axis of symmetry, then find the coordinates of the vertex, first by substitution into the quadratic and then by using the formula. Okay, so for 10b number 3, I know a is minus 3, b is minus 12, and c is 1. So if I've got x equals minus b over 2a, then that's minus negative 12 over 2 times negative 3, which gives me negative 12 over negative 6, positive 2, negative 2. Sub into, to find the y coordinate, sub in x. So we've got y equals negative 3 times negative 2 squared, take 12 times negative 2, not 1, 2, plus 1. So I've got y equals negative 3 times 4 plus 24 plus 1. Negative 3 times 4 is obviously negative 12. So y is going to come out as 13. Using the formula y equals minus discriminant over 4a, which is minus b squared take 4ac all over 4a, I'm going to do y equals minus, b squared is minus 12 squared, take 4 times negative 3 times positive 1, all over 4 times negative 3, which gives me negative 12 squared is 144 plus 12. Oh, I wanted a straight line there. Okay, I'm not getting one. Over minus 12. 144 plus 12 gives me 156 over 12. Sorry, over negative 12. Gosh, I don't have my calculator. I wish I knew what went into that. 156 is 13 times 12. So I've got 13. Hooray, because that's 13, that's 13. That's all we needed to prove. That's 13, and that's 13. Done.